So I'm going to try to explain the distributive property by using a couple of different visuals. That way when you try to understand what the distributive property is, you can say, oh, I remember this example with the blocks, or I remember this example with whatever it may be. So let's start with this first one. I've got two different blocks here, block on the left and block on the right. If I look at the block on the left and I were to say to you, what is the area of that block, you would tell me it's 3 times 2, which is 6. If I were to say what's the area of the block on the right, you would tell me that is 3 times 5, which is 15. If I were to say what's the total area of both blocks, you would have said that's 6 plus 15, and if I were to write that as an expression, it would look something like this. Like if I were to say 3 times 2 plus the other block, which is 3 times 5, well, 3 times 2 is 6, and 3 times 5 is 15, so therefore we'd have 6 plus 15, which is 21. So there it is, writing them out as two separate blocks, right? But now, let me try to write them as a group of two blocks together. And what I mean by that is, let's push these two together and pretend that it works perfectly. Okay. They both had the same height of 3. This one had a length of 2. This had a length of 5. So together, there they are as two blocks now, right? So if I were to ask you what's the area of that one now bigger block, you would say that's the area of 3 times what's the length of the bottom now? It's 2 plus 5. Following the order of operations, you would say that 2 plus 5 is 7. So then this would look like 3 times 7, which is 21. And if you remember, that's the same as what we had before. And I'll write it again just so you can remember what it looked like. Okay, those equaled the same thing, didn't they? Now, what I'm saying is, what if I were to say that 3 times 2 plus 5 is the same thing as 3 times 2 plus 3 times 5. Is that true? Now look at it. 3 times 2 plus 5, which is 3 times 7, was 21, right? So 2 plus 5 is 7, times 3 is 21. 3 plus 2 we said was 6, and 3 times 5 is 21. So now we have, 3 times 5 is 15, which gives us 15 plus 6 is 21. So this means that these two are equal to each other, right? So I'm going to do another one here with just numbers. I'm going to say that 5 times, and in parentheses, 2 plus 3 is the same thing as 5 times 2 plus 5 times 3. Now let's check to make sure that's still true based on the last slide. 2 plus 3 is 5. 5 times 5 is 25. Okay, let's see if this is still true. 5 times 2 is 10. 5 times 3 is 15. Now we add them up. 10 plus 15 is 25. Yeah? Okay. Since that's true, that's actually the distributive property. What I did there, I could say that 5 times 2 plus 3 is the same thing as doing 5 times 2 plus 5 times 3. And that's what I did right here. I actually spaced them out. That's distributing. So let's do another visual here. So you and two friends went out trick-or-treating. Here are your bags. Here's all three of you. And then inside those bags is candy. Then at the end, you came to my room and you're like, hey, Mr. Sauter, trick-or-treat. And I was like, okay, fine, I'll give you some candy. So I gave you each 2 pieces. Now, assuming that you guys, when you went trick-or-treating, stopped at all the same houses and you got the same amount of candy, each bag should have the same amount of candy in it, right? Okay, so we're going to assume that each bag has the same amount of candy, and I just gave you each 2 pieces more, right? Okay. What if I were to tell you that you guys didn't have a really productive spread and you only got 20 pieces each in that bag? Okay, now each of you had 20 pieces and you just got 2 more, right? If I were to say to you, how much total candy is there amongst all 3 of you? Well, you could do 20 plus 2 and 20 plus 2 and 20 plus 2, right? We could simplify that to say 22 plus 22 plus 22. And then we could finally say that 22 plus 22 is 44. 44 plus 22 is 66. We could say there's 66 total pieces of candy, correct? Okay, But now let's do this a little bit better. What if I were to say that the three of you each had 20 plus 2? That's your bag and the 2 extras that I gave you. Is that the same thing? Well, you could say that 20 plus 2 is 22, and that would be 3 times 22, correct? 3 times 22 is 66. What if I said 3 times 20 plus 2? Is that the same thing as if I did 3 times 20, which means 3 times the number in your bags and 3 times the number that I just gave you, right? Let's see. 3, and then I do 20 times 2 is 22. 3 times 22 is 66. 3 times 20 is 60, and 3 times 2 is 6. Then I would do 60 plus 6, and I would get 66. So again, I got the same answer, and that is the distributive property. The distributive property also works for subtraction. Let's try it. If I were to say 5 times whatever 3 minus 1 is the same thing as 5 times 3 minus 5 times 1. Let's see if that's true. 3 minus 1 is 2. Then I would do 5 times 2 and say 10, right? Okie doke. Let's go here. 5 times 3 is 15 minus, what is 5 times 1? That's 5. 15 minus 5 is 10, and therefore I get the same answer. And that's showing you again that the distributive property is true with subtraction. Again, distributive property literally means I took this number 5, I distributed to the 3, I distributed to the 1. So over here, that's 5 times 3 and 5 times 1. Now look what I did here. This subtraction sign, I did not change it. It still says subtract in between these. So it says subtract on the left, and it says subtract on the right. And I still have to do that. I can't just get rid of that symbol. Now I can't make this all too easy on you. I got to throw you a little curveball. So let's do 25 minus 4 and then 3 plus 1. Okay, order of operations says I do not do this 25 minus 4 first. If I did that first, I would get 25 minus 4 is 21, and then I would do 3 plus 1. I would do 21 times 4, which would give me 84. That is completely wrong. No. We're not going to do that. What you do need to do is follow the order of operations. And this means that we do, let's go this way first. Before we try to even distribute, let's just do this. 3 plus 1 is 4. So I'm going to rewrite what I have. Now I say 25 minus 4 times 4. 4 times 4 is 16. Now I have 25 minus 16. 25 minus 16 is what? Let's get the calculators. Let's think real hard. Use our fingers and toes. We should say that's 9. What I really want you to pay attention here is how this subtraction thing worked. This says 25 minus 4 times whatever this is, meaning minus 4 times all of it, right? As in 4 times whatever is inside of here, subtract that. Whatever's inside here with 3 plus 1 was 4. 4 times that is 16, then we subtracted it, right? So I would subtract whatever is inside of there times 4. And here's where people like to get confused. When I go to distribute, I would say 25 minus, now I do 4 times 3, so I need to do subtract whatever 4 times 3 is. And I need to subtract whatever 4 times 1 is. I need to subtract because that's what that says. It says subtract all of it. That means I can't just pick and just subtract from 4 times 3 and then say add 4 times 1. No, I need to subtract everything that's happening over here. So everything over there means subtract this and this, correct? Let's see if that's still the same answer. 4 times 3 is 12. 4 times 1 is 4. So if I were to rewrite that, that would say 25 minus 12 minus 4. Okay. What is 25 minus 12? 25 minus 12, again, fingers, toes, calculators. Oh my gosh, it's 13. 13 minus 4. What is 13 minus 4? Because remember, I'm going to bring this down over here. 13 minus 4 is, I ran out of fingers, it's 9. Now, is that the same answer? It is. This shows you have to make sure that you subtract everything that's happening to that. I'll do another one. For this one, I want you to pause the screen and work along to make sure that you are doing this the same as I am. So we know that we're not going to do 30 minus 6 first because I've told you that's wrong. It's never going to be right, okay? If you were to do 2 plus 2 first, which is 4, and then you would do 6 times 4, which is what? Right, it's 24. You would say that's 30 minus 24, and you'd say that's 6, right? Okay, so we know that our answer should be 6. Let's see if we can do it the same way using the distributive property. So I'm going to do 6 times 2, and I'm going to do 6 times 2 over here. But remember, I am subtracting everything that's there. So I'm going to say 30 minus 6 times 2. And I'm going to do 30 minus 6 times 2, and another 6 times 2, correct? Let's go to the next line. 6 times 2 is 12. 6 times 2 is 12. Now I have 30 minus 12 minus 12. Well, 30 minus 12 is what? 18. Awesome. Now minus another 12, I get what? 6. Is that the same answer? Yes. Okay, but now what happens if there is a subtraction inside the parentheses? Now I've got subtraction and subtraction. Now, that might play a little trick on us. So let's just do this straightforward as if there was no distributive property. We would do order of operations to say 3 minus 2 is 1. So to rewrite this, we'd say 60 minus 4 times 1. Then we'd come down here and say 60 minus 4 times 1 is 4. 60 minus 4 is what? Awesome, 56. Okay, now let's try doing it with the distributive property. So we need to remember that our goal is to get to 56. So the first thing I'm going to do is I'm going to distribute this 4 to both of these. So I have 60 minus 4 times 3 and minus 4 times, but look at this. I have a negative 2 there, don't I? I know you're going to say, well, but no, it says subtract 2. And remember that I said that minus 2 or negative 2 mean the same thing. Like if I said, what's 5 and what's the opposite of 5, you'd tell me that's negative 5. What's the opposite of negative 3? It's 3, right? So keep that in mind, that this means the opposite of 2 also. Okay, so now I've got what's written here is 4 times 3 and 4 times negative 2. And remember that I'm subtracting both because that's what this says. Subtract all of this. So if I come down here, I'm going to rewrite 60 minus 4 times 3 is 12. Minus 4 times negative 2 is what? 4 times negative 2 is negative 8. Okay, so now I'm going to go to the next line. 60 minus 12 is what? It is 48. 48 minus negative 8. Okay, remember that whole thing, minus a negative. 48 minus negative 8, it's either 40 or 56, I'm not sure. Well, it is 56. So look right there. We got the same answer, 56 and 56. So when you're distributing, if there's a subtraction sign inside, you need to treat that like a negative when you come to here to multiply. So then you still have this subtraction going here, and now this sign comes down here. So now you're saying is like, why do I need to know that? I could just follow the order of operations. Well, what if you threw a variable in there? Meaning, what if we said 40 minus 3 times A plus B? Trick now. I can't combine A plus B because I don't know what A plus B is. So now I'm going to have to actually distribute and do what that says. So I'm going to come down here, I'm going to say 40 minus, and then 3 times A is 3A, right? Or 3 times A. And then I'm going to do 3 times B, and remember that I subtract it. So this would be, I can't combine any further, can I? So I'd say 40 minus 3 times A is 3A. Minus what's 3 times B? It's 3B. Can I combine anything else on that screen? No. Now my final answer would be 40 minus 3A minus 3B. Let's do a simpler one with just addition. 5, and I cannot combine x plus y. So it's 5 times x plus y. Well, I can't do 5xy. That's not true, is it? Because that would mean x times y, which this does not say. So instead, I need to do 5 times x, and I need to do 5 times y. So I get 5x plus 5y.